be operating all the time at one particular load. You may have load fluctuations. So that is also important. But these are the basic specifications, and from there he starts making his proposal, or he basically putting the boiler together. So what are the basic steps? The first thing he will do is calculate the heat duty of the boiler. You are saying the boiler, define the boiler in those terms. But for the boiler engineer, his language starts with heat duty. He will first convert all your numbers into heat duty. How does he convert that? He calculates the enthalpy of steam. Enthalpy changes with pressure and temperature. So for that pressure, that temperature, what is the enthalpy of the steam? Enthalpy is always stated as kilocalories per kg. That means every ton of steam that you want this boiler to produce will have, let's say, 3000 kilocalories per kg per kilogram of the steam produced. That has to come from the burner, isn't it? But the boiler has to basically deliver that much of heat duty or heat into the steam. So that is called the boiler heat duty, right? Total multiplying the enthalpy with the rated steam generation. Enthalpy is kilocalorie per kg times 25,000 if your requirement is 25 guns. That becomes the enthalpy of steam. So that becomes the heat duty, which is expressed as kilocalories per kg or per hour or megawatt or HP. I hope you are clear about kilocalories per hour as being different from kilocalorie per kg, because kg is already covered in the tonnage. So this boiler will have to deliver so many kilocalories or so many kilowatts or so many HPs every hour. That becomes the heat duty of the boiler. So from the heat duty, what does it do? Step 2 is calculate the burner heat duty. So one thing to understand is every equipment has its own efficiency. If this is a boiler and this boiler is supposed to deliver heat duty equal to H, this is final at your doorstep, what we call as battery maker tie. But this will come from this unit, which will have its own efficiency, say efficiency of the boiler. And where does this heat come from? Come from the burner. So if the burner also delivers only H, will you get H here?
Unless it's 100%.
Unless it is 100% efficient, which is not the case. So from this H, you go to the burner heat duty, knowing that the boiler of this type will be, let's say, 90% efficient. So if you need 100 kilocalories per kg to come here as a number, you should have 110 here. The 10% will be lost from the burner to the delivery point. Okay. So step 2 is to calculate the burner heat duty.
So what is the basis of choosing the boiler efficiency number?
That comes from experience.
On size?
Yeah, actually, when you say a fuel is gas, already the boiler designer knows this will be a gas-fired boiler. And for a gas-fired boiler of 40 tons per hour, he already has a particular model in his mind. And with the experience of that design in the past, he knows it is usually 90% or 92%. So it's basically on the previous data. But back in the early 1900 years, 1920, 1930, they did all the work by themselves to calculate the efficiency of the operating boiler, and they then the benchmark. Oh, typically this type of boiler is 90% efficient. This type of boiler is 80%.
So it doesn't govern in any standards or?
No, it's not a standard. It's not a standard. It's only by competition. One company is offering you 92% efficiency, other is offering 93% efficiency. That's a better boiler for you. But it is not covered by ASME standard or anything. And not to disregard the standards, I just want to tell you, the standards are applicable to very limited area in boilers. Most of it comes from your decision and your experience. Most of it. Basically, when you work on the boilers for so many years, then you realize the standards are basically a very small portion which only take care of the safety of operation. But when it comes to economics, you see the only factor which Aisha said was price. She never talked about safety, reliability, or ease of operation. That's correct, because the mindset of all the industry people, especially the top people, price. So, under this banner of price, things like efficiency, ease of operation, reliability, these automatically get addressed by competition, because every company is competing. But unfortunately, there is no standard or no code which says that the efficiency should not be less than 93%. That's the thing I'm telling you. So, the next step will be to decide what burner we should select in order to give this delivery parameters. So, simple thing is, you already know the boiler heat duty. From the boiler heat duty, you get the burner heat duty by multiplying with efficiency. If efficiency is 90%, divided by efficiency. So, you get the total heat released to be released by the burner. So that becomes the burner heat duty. From the burner heat duty, you have to decide how many kilogram of fuel should be fired. Because you know 1 kilogram of fuel gives you so many kilocalories. And then you know how many kilocalories are to be released by the burner. So the burner should fire that many kilograms of fuel. So you come to the point where you know how much fuel will be required.
This one, it says that for the burner heat duty, we rated steam enthalpy at MCR. Why is it at MCR? They say that why not is at peak load?
Okay. You are right. Basically, all the design is made at MCR for MCR, and then we add everything as 10% peak load, and then we add a 5% operating margin. Why? Because we started with the customer requirement of NCR. And you are right, it could be NCR also. Some people will do that. If they first take the NCR number first here, instead of saying X ton per hour as NCR, what they take is X tons times 1.1, if 10% is the peak load. And then everything goes up by 10%. That's okay. But trying to say that if this point must be fixed beforehand, before we start the actual this stuff. Zamani, come here. Okay, so then you get to know the amount of fuel to be fired. The third step is to fix the furnace geometry. Now this is a tricky issue. You only know that this burner will be firing let's say 2500 kilograms of fuel gas per hour. From there, how to decide the furnace geometry? The step there is now I turn this page because you have left your office from the boiler manufacturer, and this is the office of the burner manufacturer. So you have just walked into the burner manufacturer's office, and you're telling him, my friend, I have to fire 2500 kilograms per hour of natural gas. I want a burner. He will say, okay, how many burners? You don't know. How many burners? You want one burner or two burners? Let's say we say one burner because Aisha just said price. Okay? I have to keep in mind.
Okay.
Aisha's requirement.
That's the ultimate.
Okay? I say one burner. Okay, one burner, fine. So then there is a chart which is standard document for all burner manufacturers, but developed over a lot of years of experience and research. Basically, that gives you the flame diameter versus heat. when the heat duty, meaning the kilogram of fuel fired, increases, the flame diameter also goes up. Flame becomes wider. Similarly, there is also a chart that also is the linear relation where your heat duty versus the length of the flame. So he will just look at his charts and say, okay, if you want one burner to be able to fire so many kilograms of fuel with this kind of composition, then the diameter of the flame, let's say, will be 3 meters. This is your operating point. And the length will be say 5 meters. So now you go back to your office on the same page still, because we have to be environmental friendly. Now you draw the plan view of your furnace, plan view, in which you know that the flame is going to be 5 meters. So the depth of the furnace, the plan view, will be, if this is your burner, minimum 5 meters is just for the flame, and minimum 3 meters will be for the diameter, flame length and flame diameter. So this we can actually call the flame envelope. Then we have some margin, usually it is supposed to be 300 millimeter on each side. That becomes the furnace wall. So this is your furnace wall, the blue color. Similarly, on the depth side, you have 5 meter at the end, to the end of the flame. You require some margin after that. Let's say 2 meter. So your furnace is now becomes 7 meter deep and 3 meter plus 600 mm. Let's call it 3.6 meter. This is 3.6 meter. So this decides the plan view. Okay. Now, since we had only one burner in mind, and now try to develop the front view, elevation view, front elevation. Basically, this dimension and this dimension will be the same. There is only one burner, so it's a circle uniform. So, if this is the flame envelope, if we already decided this as 3 meter, this also will be 3 meter. Okay. So, from the flame diameter of flame geometry, we have come to the size of the furnace, shape of the furnace. It will be so much deep, so much wide, so much tall.
Just a question.
Yeah.
For the burner, is it just equal factor, or if you want to use 2 or 3? How do we decide if it's sufficient to have 2 or 3?
That's where the something which you did not tell me,
Then we call it.
because you did not have that in mind, is this.
Okay.
Because it was not your requirement. So I would have gone with one burner, and then you would have come back to me, oh, I cannot run less than 50% load. You never told me. Or you want to have an N+1 philosophy. So the operation philosophy, you will decide how many burners you need. That's one part. But one important thing is, every burner has by experience, a limit of heat release. For example, when you say, my car is 4-cylinder, some cars are 8-cylinder, some are 16-cylinder, and so on. Why do we have to go for 16 cylinders if 4 were supposed to be enough? Because every cylinder has a limit to its capacity. So similarly, the cylinder is exactly the same as burner in the case of a boiler. How many burners you have, similarly how many cylinders you have. As you go on increasing the capacity of the boiler, then you have to increase the number of burners also. It so happens like this, that each model, let's say you take the biggest standard model of a burner. Normally it is supposed to be around 60 tons per hour. That means if this is the heat duty, if this is the heat duty and this is the number of burners. With heat duty, increase of heat duty up to number 1, no, sorry, this is the number of burners and this is the heat duty. Your heat duty is go on increasing, let's say from 10 kilocalories per hour, very small, to let me say 1 million kilocalories. 1 million. So for up to let's say 1 million is coming here. Up to so much, which is equivalent to, let's say, let me say equivalent to say 60 tons per hour of steam. One burner is enough, so you can maintain one. But as soon as you increase from here to here, this burner cannot perform anymore and you enter into the zone of 2 burners. The number of burners will change to 2. Then you go from here up to this, let's say equal to 120 tons capacity. Then you go switch over from the zone of 2 burners to a zone of 3 burners. So it's like a step that every step you have come to end, then you change to the next burners. So let's say if you are just at the border point here, let's say here, where it's already up to the full capacity of 2 burners, and even 5 ton more also you have to go to 3rd burner. Then you take a conscious decision whether you want to really worry about it or you just manage the 2 burners, pushing it to its limit price. That's where one company's designs are considered as more user friendly, less troublesome compared to other. Technology is still the same. Everybody uses the same technology. Boiler technology is not something which is invented yesterday. It has been there for 200 years. It's only how people use the technology to customers' advantage or to their own advantage. Because as you would have seen from this live example, Petronas did not specify how many burners. The choice was left to the EPC or the boiler design. And if the heat duty required by the boiler happens to be just at the border point of 2 and 3, a money making company would have selected 2 burners.
2 instead of 3.
Yeah, because he spends less. 2 burners means that many less scanners, that many less instrumentation, that many less shut-off valves.
I thought they are trying to sell more burners.
He buys the burner.
He buys.
Boiler maker doesn't make the burner. And at the end of the day, he doesn't tell you that I am selling you more burners, so give me more money. Isn't it? With the price cap already fixed, if he can manage, for example, you go to MLNG, they have a 380 ton boiler, but only 2 burners. One burner, I could walk through the burner without waiting in the circle. But what issues they have? Huge. When they first fire the burner, the boiler the whole thing shakes. Because it is catching fire at the minimum flow, which is equivalent to 60 tons per hour steam generation. It's bigger than our boiler. As a starting fire, it's one burner designed for 190 ton delivery, plus peak load of 10%. And you can imagine for lighting up that burner, you require, let's say, 20% of the minimum load, as minimum load. So 190 plus 10% is about 210. 20% of that is like 40 tons, 40 or 45 tons. So imagine it is bigger than the starting point from coal. The first fire in the burner is taking fuel more than our whole auxiliary boiler. And if something goes wrong at that time, maybe instrumentation fail or scanner fails, there is no fire but it gives the wrong signal, there is already a flame, actually it's not combusting, you can imagine what will happen. So this is again an example of cost cutting, with the buyer not knowing what he is buying. He only thinks I specified I want so much in duty, and he never realized that so much can be manipulated under the drawing sheet. That is what has happened. So it's when you go for selecting or doing the engineering review, for example, you should know the question: why are there only 2 burners? My boiler is supposed to be 150 tons. Why only 2? Why not 3 burners? Why not 4 burners? You go to PFK, 120 ton boiler, 120 ton burner, 3 burners. Go to CF Karte, auxiliary boiler, 100 tons only, 3 burners. You will see most of the boilers As soon as the nameplate changes to beyond 60 tons capacity, 60 TPH, they have to have more than one. 120 TPH, they have to have more than two, and so on. That is one reason. And I already explained indirectly so that if you have a very big burner, then the jerk it gives to the furnace during the first fire is also big. And then your furnace starts to shake, and how many starts you give to the burner, that many times it has gone through a mechanical impact cycle like an earthquake. So that is one criteria. Second criteria is how much turn down you require from the boiler. One burner can turn down from X to 1/4 X, 25% normally. But if you want a whole boiler, let's say now, while ordering the boiler, you order for load range of 20% to 100%. Take this case. Our requirement is boiler load should be able to cater to 20% to 100%. Okay, fuel firing will be linearly increasing. In auxiliary valve is more or less linear. So at 20% you will expect 20% of the NCR load. At 100% you will expect about 100% of the NCR fire capacity. Then you also have to have peak load 10%, and then you have to have a standard margin of 5% over the peak load. So 110 plus 5% of 110. This is 100, this is 110. So 110 plus 5% of it will be 5.5. So 115.5 equivalent. So your burner design point is here. And normally the turn down of a burner is supposed to be 25%. Means from full rated capacity to 1/4 of it. You can modulate the fuel flow. So if you take this as the design point for the burner, your 25% will be somewhere here, which means you cannot run the boiler at 20% load. But you specified it that the load can vary from 20% to 110% peak load. So will one burner be sufficient in that case? Because you needed 20 ton steam on stable basis. You selected a burner for, let's say this was 100 tons per hour. So the burner was basically designed for a heat duty equivalent of 115.5 TPH. What is the turn down? 1/4 of this will be roughly 30. Say 29. Okay. Let's call it 30. So you try to go below 30 tons, the burner may trip. So how to bridge this? How to make sure that 20 ton is within the turn down of the burner? That means this 20 figure should be 25% of something. How will you get that? Only if the burner is rated for 80 tons.